Hey Geometry Geniuses, I wanted to talk to you today about vectors and their applications. These are our objectives. We'll eventually be interpreting and writing about vectors using the proper notation. We might even calculate the magnitude and direction of select vectors, add some vectors, and solve some applications with navigating using vectors. So what exactly is a vector? If you've taken physics, you might have already heard this term, but I'll give you a quick refresher in case you haven't taken it or you're going to take it, which you should. A vector is any quantity that has magnitude, so some type of size. It might be a square or a cube, or maybe it's a dot, but it's something that takes up space, and it has a specific direction that it's going in. For example, we can describe the following vectors. If we had a car traveling at 50 miles per hour in a direction due east, we might draw something like this. This is me drawing a car. This is the kind of car I drive. Yeah, there's this really big bubble in the middle. So it was going east. We could say that it has the car in a direction going east, so to the right, if we're using this as a northeast-southwest type of scenario. A person walking 2 miles, 30 degrees south of due west. So this is a little bit more challenging, but 30 degrees south of due west. So it's as if we would have, northeast, southwest, but we're 30 degrees south of that. So we can assume that this is where that person's walking in this general direction. The wind blowing 20 miles per hour due south. Let's say that we have this bubble here, and we say that that's going to be going south. Cool. Kind of looks like a person, but let's say that it's really a cloud. We can use an arrow to describe a vector. That's what we've already kind of seen. For example, if we start at point A and end at point B, we can use this notation for vector AB. So notice that it's AB, and then we have this little arrow up here to show that it's going in some direction. Similar to array, which we've seen before. We call A the initial point, B the terminal point. These move in the coordinate plane. We'll describe how these move in the XY plane, and we'll take this further from here. In this first example, what is OL as an ordered pair? Well, let's sketch out this so you can see a little bit more. We have our x-plane, we have our y-plane, we have 50 degrees in here, we have a length of 65, and we're being asked to give the vector. Well, this is where trig is going to fall back into place. So we have this angle of 50, and we are trying to pinpoint this coordinate here as an xy plane. So what do you think? What could we do? What trig function could we use to take this further? Well, we need an x-coordinate, and we need a y-coordinate. So let's think. We know that across from 50 degrees is y. So across from 50 degrees is y. Our hypotenuse is 65. This could help us solve for y, right? So we know that if we multiply both sides of this by 65, 65 here, 65 there, y will be equal to 65 times sine of 50. So that'll help us get the y-coordinate. How can we get the x-coordinate? What do you think? How can we do that? Well, I know the x-coordinate's up here. I know that I can still use 50 degrees, but let's try it with cosine now, where our adjacent is x, and this is over 65, senior citizen age. If we multiply both sides by 65, 65s can cancel. We can get that x equals 65 times cosine of 50 degrees. We can let our calculator take care of the rest, and we'll do that now. So let's see, what are we doing? For our y-coordinate, we said that we were going to do 65 times sine of 50, so that's pretty easy. Of course, make sure that you're in degrees. So this is approximately 49.79. And we're rounding to the nearest hundredth, so I'm just going to call this 49.8. So approximately 49.8. Wait, no, we're going to the hundredths, so my bad. 79. Yeah, I was right. Tenths and then hundredths. Cool. So we got y. Let's get this for x. We got 65. But now we're doing cosine. Still at 50 degrees. So this is approximately 41.78. So as an ordered pair, we know that the x-coordinate was 41.78. And our y-coordinate was approximately 49.79. So that'll work for this vector. So this was vector OL, where our initial point was the origin, and our terminal point, so here's that vocab, terminal point was that answer that we just found. Pretty cool. Let's see what else we got. We can describe these vectors if we move in certain directions, similar to a compass. We can take this further. All right, so describe the direction of the vectors below. So we have this vector starting at W, or starting at the origin, kind of spacing out. So we could say that this vector is traveling 25 degrees. I always use the angle that's above it in this case. So 25 degrees, let's see, south of east. Because it's in the southern direction, but it looks as if it's going toward east, so it's kind of southeast. And I always try to go with the angle that's smaller of the two, personally. So with this one will actually kind of sound weird, but I mean, I guess there are a few different ways that you could talk about this. You could say that this vector is traveling 30 degrees west of south. Or, I suppose this is another way. Yeah, I think these both work. You could also say 60 degrees south of west. Southwest. Philly, stand up. Lansdowne, where you at? Yaden, where are you at? I think this actually covers a lot. I mean, in physics, you see this a ton. We saw the examples with the real world situation. If you have any questions on this, bring them to class. Thanks for watching.